Hello everyone. So today I'm going to do 4C from dynamics of particle moving in a straight line. I'm going to do number 9 first. These are actually conceptual sums, so you need great focus and great understanding at the same time. So let's begin. The question says a lift of mass 500 kg is lowered or raised by means of metal cable attached to its top. The lift contains passengers whose total mass is 300 kg. The lift starts from rest and accelerates at a constant rate, reaching a speed of 3 meters per second after moving a distance of 5 meters. Okay, so the total mass is 500 plus 300, which is 800 kgs. Then we have a metal cable, so there must be a tension force. Starts from rest, so U equals 0, and accelerates at a constant rate, reaching a speed of 3 meters per second, which is V equals 0. And we have the displacement as well, displacement or distance, which is 5 meters. Find the acceleration of the lift. Part A asks for the acceleration of the lift, so let's begin. So to find the acceleration, we could use the formula v squared equal u squared plus 2as. We need to find a, so we could substitute all the values that we know. A equal v squared minus u squared by 2s. We know v is 3, so we could write 3 squared, which is 9. It starts from rest, so u equals 0, so we could directly write 0, or we could directly write 9. We also know the distance, which is 5, so the acceleration is 0.9. From the calculator I will show you. You can see it's 0.9. We must give the unit, which is meter per second square. Okay, let's move to part B. Part B asks for the tension of the tension in the cable if the lift is moving vertically downward. So the lift is moving vertically downward. In such cases, you need to draw a diagram usually, so that you can get the concept more, nicely, and you can do the maths more easily. So let's draw a diagram for B. Yeah, part B. We could draw the lift and the passengers all together like this. So they all have a mass of 800 kg. So the weight will be 800 into g, which is 800 grams. 800 into g, which is 800 g. It's not grams, it's gravity. This is the weight. Similarly, we have a force of tension, as I mentioned earlier, that as it is hung by a rope. I should also show the rope. This is the rope here with which the lift is hung with, right? So this rope is giving a tension force as well. We saw in the question that it is moving vertically downwards, so it's accelerating downwards. So we could show it like this way. We found the acceleration earlier on in part A, which is 0.9. So it is going downwards. We know that, right? Another thing that people get confused about is that where is the tension acting? The tension is acting upwards, okay? Or the weight is acting downwards and the tension is acting upwards by the rope. So we need to find the tension. Part B asks for tension of the cable if it is moving vertically downwards. So we know that there is a resultant force. That is why it is going downward, right? Because without a resultant force, it would be in the same position, right? It would stay here. It wouldn't move downwards. And without a resultant force, there would be no acceleration. So if there is acceleration, there is resultant force, vice versa. So the resultant force, we know force equals to mass into acceleration, right? We know the mass, which is 800. We know the acceleration, which is 0.9. So we know the resultant force, because this is resultant force. Yeah, I would calculate, and it gives 720 newtons. 720 newtons. Okay. Now we know the resultant force is acting downwards because it's accelerating downwards. Therefore, we could write tension subtracted from weight is the resultant force, because weight is acting downwards as well. So weight minus tension. You can see weight is acting downwards, whereas tension is acting upwards. So they are in opposite directions. So we will minus tension from weight to have our resultant force, right? This is the main thing here, that it is acting, it is moving downwards, so the weight is more than the tension, right? That makes sense. So the resultant force should be something that's the weight minus the tension. So we know the weight, 800g. 800g is 800 into gravity, minus tension. We don't know tension. We are supposed to find tension, and we know the force from here, 720. Okay. So for 800g, we know in M1 and A levels, the gravity is 9.8, which is minus T equals 720. Now if I move T, therefore 720 should be subtracted from the 800 into, 800, what 800 into 9.8 minus 720, which gives us a tension force. Never mind, I think I made some mistake. So if you move T here, then 800 into 9.8 minus 720. Okay, that should be it. 800 into 9.8, this is 7840. So minus 720, let's see what's the answer. 7120. So weight minus tension equals 720. So if I move tension there and take 720 here, so 800 into 9.8 minus 720, which gives us 7120. And we are done with part B as well. So let's move towards part C, which asks the tension of the cable if the lift is moving vertically upwards. Now they asked for the tension again, but this time the scenario is a bit different, right? The lift is not moving downwards anymore, it's moving upwards, so it's accelerating upwards. I will do it here so that we have the whole maths. For part C, we should draw the diagram again. Weight is acting, obviously always weight is acting downwards, as we know. Now as it is moving upwards, the acceleration is 0.9. It's upwards as well. The tension is again T, because the rope is pulling it upwards, the weight is pulling it down, pushing it downwards. So yeah, this is the scenario again, but this time acceleration is upwards. That's the difference between B and C. We know the resultant force again, it's the same. Resultant force is resultant force should be this time same, right? Because the acceleration is same, the mass is same. So resultant force again, it's 720 newtons, right? Now we will subtract weight from the tension, which is tension minus weight equals to the resultant force, because this is acting upwards. Thus it means that the tension is the main force, that's the resultant one, you could say, right? So tension minus weight, because tension is acting upwards, weight is acting downwards, it's accelerating upwards, so it's in the way of the tension, right? So tension minus weight equal force. Again, we don't know tension, we know weight, which is, we found 800 into 9.8. Force is still 720, obviously, because the mass and acceleration is same. It's constant acceleration. So T equal, I'll move this thing here, so it will give us 8560 newtons, and that's it. I would give you a tip that always draw diagrams, so the arrow with the acceleration where it's going, so it's, when it's visually done, it's easier to solve the maths. Otherwise it could get a bit harder maybe. And M1, I've seen so far that if you draw visual representations, a lot easier than doing it by just mentally calculating or just with the numbers. So yeah, so this is the whole maths here for C9. If you want, takes